Hi Physics, this is Miss Satterley. This is mainly for the remote learners. I'm going to go over work and power. So there's a homework assignment that I've posted the equations with, but I'm going to walk you through those equations so then you can do your homework. And then I'm going to go over a couple practice problems as well. So first off, work is the product of the component of force exerted on an object in the direction of displacement and the magnitude of displacement. So that is the definition of work. So when we do these equations, we're going to use the equation work equals force times displacement. Or in other words, W equals F times D. What these letters mean, again, W is work, F is force, D is distance. I'm going to put the units with these because this is important, because when you're looking at problems, you need to be able to recognize if you have 22 joules, what that actually means. So the unit for work is the joule, which is J. Force, you should know, that's newtons, which we have as a capital N. I'm going to change this. And then distance is in meters, which is little m. So that's the first problem that we're going to have. The other thing I want to do is I'm going to go ahead and derive those equations based on what we're solving for. So again, if we're solving for work, it's just going to be force times D. If you're looking for force, what you're going to do is have W divided by D. So you're going to divide both sides by that. And then if you want to find distance is going to be W divided by force, or work divided by force. So those are your equations that you're going to use when you do these problems. Now, the second thing we're going to talk about today is power. So power is the rate of doing work. So this is the rate at which work is done. So if I was going to write out my equation, power equals work over the amount of time that it takes for that task to be completed. So that would be P equals W over T. Again, let's go over the units for our equation for power. So we have W. W is work. We have P. So P is for power. And then T should sound familiar. T is for time. And just so we have it here, we're going to put our SI units with these. The unit for power is the watt, which is also a W. Work, again, is the joule, which is a J. And time, we should know, is seconds, or S. So these are the equations. Again, let's put these. P equals W over T. If I want to solve for work and I'm given a power and time, work equals P times T. And then for time is going to equal W divided by P. So I have this information on a document that was loaded up with the assignment, but I just wanted to verbally walk you through how to do this. Okay, I have 3 examples we're going to walk through. Okay, so number 1, Bud, a very large man of mass 130 kilograms, stands on a pogo stick. How much work is done as Bud compresses the spring of the pogo stick 0.050 meters? Well, the one thing you have to do here is I'm missing a force. I don't have a force for this. I have nothing that's newtons. I do have a weight or a mass. So I need to use the equation W equals mg, which is weight, to convert my mass to newtons. So we're just using gravity, 9.81 meters per second squared. When I multiply this together, I get 12,075.3. Well, I need proper sig figs. So in my equation, 130 only has 2 sig figs. So my proper sig figs is 1,300 newtons. When you do these problems, I want you to go ahead and highlight the information in the problem just so you can see it better. It shows me that you're identifying the information in your problem. I'm also going to go ahead and highlight this because this is also something we'll need. So now that we have our units, we need to solve for work because we want to know how much work. So again, work equals force times distance. I'm going to plug in my information. I have 1,300 newtons, and we're going to multiply it by the distance, 0.050 meters. When I put in my information, I'm going to get 65. Since it's work, it's going to be 65 joules. So that would be my final answer, and I'm going to go ahead and make that a different color just to distinguish between my givens or the information I need to solve it. All right, let's do number 2. After finishing her physics homework, Susan pulls her 50.0 kilogram body out of the living room chair and climbs up the 5.0 meter high flight of stairs to her bedroom. How much work does Susan do in ascending the stairs? Well, I'm going to go ahead and highlight my givens first. So I'm going to highlight her mass and a distance. Now I have to do the same thing I just did. I have a mass. A mass is not what we need. We need to have a force. And weight is a force, so we're going to convert that. So W equals mg. I'm going to plug in my information here. 50.0 kilograms times 9.81 meters per second squared. I get 490.5. I need to have 3 sig figs. So we're going to end up with 491 newtons. I'm going to highlight that yellow because that's information that we need to solve the problem. We're going to use the same equation. Work equals force times distance. I'm going to plug in my information that is given here. So 491 newtons times 5.0 meters. My answer is 2,455. Going off my problem here, I need 2 sig figs, so my final answer is going to be 2,500 joules. So I'm going to highlight this blue again. It's our final answer. This actually ties in with the problem we just did. So in the previous example, Susan slowly ascends the stairs, taking 10 seconds to go from the bottom to the top. The next evening, in a rush to catch her favorite TV show, she runs up the stairs in 3.0 seconds. On which night does Susan do more work? On which night does Susan generate more power? Well, I want to point out here, this question right here. Work is force over distance. Susan is moving her body the same distance on both nights. So therefore, she is doing the same amount of work. So she does the same amount of work both nights. Because her mass and the distance she covers is not changing. She does the same amount of work. On which night does Susan generate more power? Well, that's the question that we have here. So we have 2 nights that we're going to have. So this is a 2-part problem here. We need to use the work from the previous problem. So work equals 2,500 joules. So there's my one given. My other given is the 3 seconds and the 10 seconds, and they're going to be separate. When we do this, we're using the equation for power. P equals work over time. So I have 2 equations here. So my first night, we have 2,500 joules divided by 10.0 seconds. That's my first night. I'm going to go ahead and copy and paste this because I already have it done. And hit enter and then just change my seconds here. There we go. So now what I need to do is divide my numbers here. 2,500 divided by 10 is 250 watts. And 2,500 divided by 3 is 833.33. And I need 2 sig figs here, so I'm going to convert that or change that to 830 watts. And to complete my question, Susan generates more power the day she runs up the stairs to catch her favorite show. That is because she is running the same amount of distance in a slower time, so she is using more energy, creating more power to cover that same distance. So this is a couple example problems for how to work our work and power problems. Okay, now that is finished. And here are those equations. They are there. If you have any questions on any of the homework, please let me know, and have a wonderful weekend. Bye.